Hey guys, how are y'all today? Well, the funny thing about it is I made this big, huge recording, and guess what? I forgot to record it. So yeah, I was talking to myself, so that's awesome. So what I would like to do is I'd like to go over the assignment that you had. Your assignment was chapter 19, section 1, and it was talking about incoherent light. Incoherent light is an object that is illuminated by a white lab source, such as a nearby light. Coherent light is a light made by the same wavelength that is in the same place, usually with lasers, and that's a single point source. Narrow, single slit, overlapping pattern of bright and dark bands, interference fringe. Monochrome light is light that is within a wavelength. The intensity of a bright band decreases the further the band is from the central bank. Generation of coherent light. These lights experience construction of deconstruction interference. And then we have our equation, which is lambda equals our distance of the screen. And then we're going to go and look at the central light of the band and then the slit of the screen. Okay, so what we're going to do is we're going to turn and I'm going to show you the math behind it. I'm sorry I've already written it out, but it's okay. So where am I? I am on page number 526, and we are going to do questions 1, 2, 3 today. Okay, so here are the answers. So what I'm going to do is I'm going to read it first. It says violet light falls into two slits separated by 1.9 times 10 to the 5th. That is the D for distance. An ordered bright band appears at 13.2 millimeters. I changed that from millimeters to meters, so that's 13.2 times 10 to the negative 3. Central band screen is 0.600 meters from the slit. That's my length. So what I'm going to do is I'm going to take 13.2 times 10 to the negative 3 meters, multiply that by 1.9 times 10 to the negative 5th meter, and then I'm going to divide that by the length, which is 0.60 meters, and you should get 4.8 meters. Number 2, yellow-orange light is sodium lamp with a wavelength of 596 nanometers. Well, 5.96 nanometers, as I'm changing that to meters, that's 595 times 10 to the negative 9 meters, is aimed with two slits that separate 1.9 times 10 to the 5th meter. That is my distance, 1.9 times 10 to the negative 5th meter. What is the distance of the central band of the first order yellow band if the screen is 0.600 meters from the slit? That's my length. So I'm going to take this number, multiply by this, divided by that, and you should get 1.88 times 10 to the negative 2 meters. And if you convert that to millimeters, it's 18.8. Number 3, in a double slit investigation, physics students use a laser, okay, at a lambda is 632.8. I changed that to 10 to the negative 9 meters because I needed to have it in meters instead of nanometers. A student places a screen at 1.000 meters of the slit. Well, there's my length. It says from the first bright light band at 65 nanometers, which I changed to meters. And it's asking us what the slit separation is. So you would take this number times this, divided by that, and you should have got 9.66 times 10 to the negative 6. Okay, so I hope this helps you out, and I hope you have a good day. There is more reading going on that's involved in the thin slit interference, and then also we have questions on page 529 and 530. I hope you have a good day.